All right, let's get started. Hello, everybody. So raise your hand if this is your first time at the Unstructured Data Meetup. Oh my gosh, I'm so impressed. This is really amazing. Raise your hand if you're familiar with Milvis. Aha. And not the lens and not the bird, the vector database. Okay, excellent. So my name is Chris Churilo, and I work at a company called Zillis. And Zillis is a made-up word, and it stands for zillions and zillions of unstructured data. And we are the key maintainers of an open source project called Milvis. And Milvis is actually a project that we donated to the Linux Foundation. I've got the wrong deck. Of course. After all that waiting around, you think I could be more organized. Here it is. Okay, so Milvis is an open source project that we donated to the Linux Foundation, and it's quite popular. And then, of course, a lot of you that are very familiar with the AI space are probably saying, oh my God, another vector database? And I'm here to say yes. And actually, my friend Chris, who's around here somewhere, I think he has, Chris, what's the latest count on vector databases? 125. 125 databases, amazing. Which is, you're probably thinking like, why aren't you worried, Chris? Well, the reason I'm not worried is that I think it's actually really exciting because things are really cooking in the AI space, and vector embeddings are an amazing way for us to be able to get insights into unstructured data. And so the fact that every database wants to work with vector embeddings is really good. It's a really good sign. And as you get to know more about vector embeddings and how to use them, especially with RAG, which we have a couple of speakers that are going to be talking about that today, you'll see that there are some very unique characteristics about vector embeddings and some workflows. And so, real strong, powerful vector databases will be able to support all these different cases and workflows that these vector embeddings have. And it's not just about vector databases. We're all excited because right now we're in this very momentous moment in engineering history where a lot of cool things are being generated with GenAI. And if we take a look at what actually comprises GenAI, it's really these three things, right? So it's the models, and everybody knows about the models because OpenAI and everybody's been getting tons and tons of money and building incredible models. I think I saw somebody from Meta, so we've got Llama, all kinds of incredible models, and these are just the big guys. There's a bunch of smaller models and a lot of custom models. And then, of course, on the computation side, NVIDIA has been making a lot of noise, and everyone's really jealous if you have a GPU. But those are really important, right, when it comes to GenAI. But the third pillar is really important. And I was actually just talking to somebody at Intuit, and we were just talking about this. And data is very, very important to GenAI. And that's, of course, where the vector database lives on the data side. But you know what? There's actually a lot of other capabilities that still need to get built to support vector embeddings or any of the AI applications or workflows. And if you've been working with applications and using databases for a long time, these words should be very familiar. You're probably going, yeah, I know ETL, security pipelines, observability, blah, blah, blah. Been doing it forever with relational databases. But they're still in this very, very early stage with AI and with vector embeddings. So if you are a developer and you're like, man, I want to start a really cool AI startup, take a look at that list. These are things that I think are going to be really important. And in fact, our first speaker is going to talk about one of these bullet points because it is really important in this AI world. And so we named this meetup Unstructured Data for a couple of reasons. One is if I just had a meetup on Milvis, you guys would get really bored because how much can I talk about us, right? And it's kind of a little bit selfish. But because there's so much work to do in this space, in this GenAI, in this AI space, what we want to do is we want to actually help to foster a community and encourage a lot of developers to start to build these other tools, especially in that data pillar. And what better way to do it than to host meetups where we can talk about these different topics, learn from each other, network, and build incredible things. So Unstructured Data is the name of our meetup, and we have a number of different chapters around the world. And at the end of the year, we are going to hold a summit. And so stay tuned for that. We're just getting those things a little bit organized. And really, you know, when you think about what's happening in AI space, you guys have probably all heard of RAG, Retrieval-Augmented Generation. A lot of hype has gone around it. A lot of people are building really cool prototypes around it. And that was just last year. And now what we're seeing is we're actually seeing a lot of these prototypes actually trying to get into production. And you'll hear from our speakers today, there are some challenges with getting RAG into production. So a lot of things to think about. In addition, it's not just about text anymore. And if we think about the beauty of vector embeddings is that it can help to give you insights into all kinds of unstructured data, which is images, audio files, videos, etc. Right? And as human beings, we can actually take all those different forms of modality, and we can also get a lot of insight. So imagine if you have computers helping you to be able to do that, how strong and powerful these applications you're building are going to be. So as you can tell, I'm really excited. I hope you guys are really excited about what's happening here. One little fun thing, if you give Milvis a star today, Sachi, who's on our team, is going to do a little raffle at the end. This is just for fun. She's raffling some swag. So I'll leave this up for you guys to take a picture of that. If you are a Milvis user, and you want to share with us, you know, how you're using Milvis, Sachi can also interview you for even more swag. Or a lot of times we'll leave a 10-minute slot at these events. So if you want to come up and do a real quick lightning talk, you're welcome to do so. All right, so with that, let's go to our first speaker. Oz, you want to come up here as I get this ready? Okay, I'll let you do that. And I'll do the quick. So speaking of community building, this is going to sound a little bit weird. So I was like tromping around LinkedIn, just looking. I don't know what I was looking for, but I was just like trying to become friends with a bunch of people. And I found this guy, Oz, and I was like, oh, he seems like somebody that would like to come to this meetup. So I connected with him. And then I said, hey, thanks for being my friend. Why don't you come to this meetup? And so he showed up. And then we chatted, and I was like, hey, you're building something pretty cool in the AI space, in particular with security. Why don't you speak at the next meetup? And guess what? He's speaking at this meetup. So good things can happen when you hang out with me. So just a little bit about Oz. So 15 years in cybersecurity, in a lot of positions in security engineering, product management, go-to-market. And he is the founder of Wasserman Security, and he's going to be talking about, you know, basically why you need to really think about how to secure your data as you're building out these RAG solutions. Oz also has a BS in computer science from Florida Institute of Tech. And why don't we get started?
Sounds good. Can you hear me? Okay. Perfect. Thanks, Chris. So hello, everyone. So my talk, as Chris mentioned, is going to be a lot about securing RAG deployments. And as you know, a lot of the emphasis when we're securing RAG deployments goes into the data. So we're going to touch a few elements and a few aspects about it. And at the end, feel free to ask any questions or put any comments in place. A little bit about me, as Chris mentioned. So I'm more of an security engineering and reverse engineer by training. So a bunch of product management positions from security companies like FireEye, Abnormal Security, and some early stage startups. I build products in data security, governance, email security, so outside of AI, but a lot of these same principles apply to GenAI and to other technology stack as well. And I'm the co-founder of Opsin. My co-founder, James, is also in the audience as well today. We'd love to connect with you afterwards. We're a company that secures GenAI, and just excited about the space in general. So stating a little bit of the obvious, but just setting the stage, right? So the Retrieval-Augmented Generation as a deployment, right, combines really the data with the foundational models to really create the relevant information specifically for your organization when it comes to knowledge bases and generating accurate responses. Because we have a lot of the data that is connected to it, it's ensuring the accuracy and the grounding of the model is much more, much better in a sense. And it's the results of it, as you all know, it's improving the accuracy, the contextual relevance, and then obviously reducing the hallucinations. And if you look at it, just again to set the stage, if you look at the workflow a little bit, and I like this systematic way from Ken Hong, is really looking at three main stages. Is the knowledge source that is indexed, and then the vector embedding is created, obviously, then stored in the vector database. And then for querying, like the retriever finds actually the most relevant context to database using any semantic search, or neighboring search. And then the context just goes to the generator, and the LLM just produces a response. So we see the great adoption of RAG because of these, like just a simple ease of usage, and then the enhancing the responses, just augmenting the pre-existing knowledge of the foundational model with our data. So it helps a lot of the accuracy. But if you see in each stage here, there are security risks that are coming. And we'll go into each stage and what security risks are entailing in each of them. So like, I know a lot of the people that sit here are developing RAG applications and sometimes are not security experts. So why the heck do we really need to secure it? And you know, there's a bunch of reasons, but I want to just focus on you as a developer. And as a developer, you really need to take pride of your work and protect your work, right? A lot of the things that we're trying to achieve with RAG and business value really relates to our business. So making sure that we produce AI applications that are safe and are protected against data breaches and unauthorized access, and it really preserves the integrity of what you're creating. Then the reliability, obviously, as a result of that, increases. There's also things like compliance and penalties. A lot of the organizations you guys are working for adhering to some of these compliance practices, and these are risks that can be tangible if data leaks or data that is regulated falls into the wrong hands. And then the building of trust with user security and privacy. So a lot of the organizations we work with and what we observe is that security, in most cases, is a reactive organization. And I think you know, the stage of experimentation and understanding what can we do with RAG is where we are right now. And a lot of the responsibility falls on the development lifecycle. And security will come a lot as maybe on the committees you guys are sitting and approving those projects, as well as a reactive organization of understanding how to secure it after it's in production. But I think for us is to really build that trust from the very get-go in order to really produce a secured environment when we're doing it. And then obviously, as a result of it, you reducing the cost of dealing with a lot of these security issues yourselves. If you're very cautious about it at the beginning, you don't have to like run around and chase after vulnerability management and so on. So like I mentioned, there's like these, just to oversimplify, 3 stages. And I want to go over each stage and where we're observing things. So there's the data source and the vector DB and all the elements of security there. The security element there, and then the security of the generation itself. So just focusing for now on the data source and the vector DB security. So there's 3 main elements that we're seeing that are the most important here. One of them is really data anonymization, and what it truly is like it's just taking a lot of this sensitive information and making sure that we anonymize it. Again, around compliance and data privacy, a lot of it is coming into how do we ensure that personal identified information and things that should not be in these models are reduced or anonymized. And if we look at it, it's really like the result of it is like preventing any unauthorized access to personal data and protecting individuals' privacy. And then there is a lot of the reduced risk of sensitive information just exploited. And at this stage, it's more about obviously storing it in the vector database. But as you guys know, there's foundational models involved in this whole process of generating that can actually pose a risk of exposing a lot of this sensitive information into these model providers. That some organization is actually a regulatory violation. And then literally just ensure we adhere to the best practices when it comes to data security. So an example of a library that helps with data anonymization, I'm sure you guys all know, is Presidio. It's an open source library from Microsoft. It's a unified SDK to do any work on privacy. So how does it work? It's literally using a named entity recognition. So you look at regular expressions, rule-based logic, and then basically building the ability to recognize these patterns in prompts and information, and then making sure that we can anonymize it and having the techniques to actually reduce that as we store it. So this work, obviously, a lot of the presentation work is falling on the developers now, and there is no way to absolute securing data or absolutely anonymize data because it's a non-deterministic system. We have to obviously be cautious about it, but a lot of the responsibility falls on the developer. So the second element is when we see it as the most pressing one is what they call access control. And as you guys all know, when we connect data, whether if it's unstructured files or structured data, to the RAG, as of this moment, a lot of the permissions and roles that we have outside of the model is just completely disappearing. So whoever has access to the model and can query, if there is not a layer to manage the roles and permissions to the data, they can query anything they want. So there is definitely a lot of risk into that when it comes to privacy. So people just accessing unauthorized information that they shouldn't be accessing to, any misuse of data. So reducing literally like misusing any type of data that is connected to the RAG. And then obviously there is regulatory implication to that. And if you look at the process, there's four main elements. So like, when you go to access the model, there's the authentication, like who has the access, whether you are in front of a SSO or the identity access management system. Then you have the authorization, who you are, what's your role. And then obviously what type of data that lives outside the model you even have access to, and you need to respect it in the model itself. And if you look at it from like more of a diagram, so again, like we're talking a lot in this meetup about unstructured data, but some organizations that we work with want to ingest a lot more than that. They want to ingest their structured data. They want to connect their databases. They want to connect CRM systems and tooling. So the way that we think the best practice around it should be some sort of an orchestration layer that looks at two main things. It's what we call authorization and permission. So it means that if I have authorization to the model and I can query anything I want, I need to have another layer of permissioning to that data. And I need to orchestrate it continuously to ensure that Oz only has access to a universe of data that he has access to outside of the model and respect it inside the model as well. And that orchestration layer helps ingest data from the development perspective securely. And then obviously as we give those LLMs either as a knowledge application or chatbots to the end users, they can only see the universe of data that they need to see. And the third element is about encryption. So basically, there's obviously the basic encryption, and this is not anything new. Any type of data at rest and data in motion has to be encrypted also with GenAI. So there's great advancements in this space, especially vector DBs like Milvus, like really working on ensuring that the encryption is there from the get-go. So there's just a basic rest and in transit, and it really depends. We're working with a lot of organizations. It depends on their use case and what they're trying to do as a business case. But we're seeing some advanced technologies of people really trying to protect the data when it's being stored into the vector DB. There's examples of tokenization, that replacing the sensitive original content with a non-sensitive one and have a pointer to it, and then the decentralization and charting. But basically, these are more advanced use cases, and if a lot of the organization just adhere to the basic encryption, that should be sufficient to a lot of the use cases that we're tackling. There is the additional measures in this stage that if your team wants to be more proactive. So it's all about monitoring, alerting on the actual database itself, making sure that the access to it, even from a maintenance and like from development perspective, is maintained to only the authorized personnel. There's obviously the backup and recovery and rate limiting that allows a lot of these attacks to be prevented also from the database itself. So that's the high level about the database stage. And then when we talk about the retrieval stage, right, as we created vector embeddings, the data is already embedded in the model, and we're trying to obviously retrieve. And here there is also a variety of things, but it's more of a subsequence of the risk that we talked about beforehand. So if we haven't really done a lot of the secure ingestion of data into the RAG model, then there is the risk of unauthorized data access, because again, anybody can access anything around that. So really the mitigation is ensuring that what we talked about earlier, the access control and the permissioning are enforced. And then there is a lot of things about the similarity search risk, and I'm sure you heard about model poisoning and prompt injection in the past, but there is a lot of the manipulation of those prompts and basically like things like the data leakage through similarity queries. So actors just doing similarity search that is an attacker can just craft a clever query that could really potentially retrieve the information that is semantically similar to the actual sensitive data. And then there is things like model poisoning, as I mentioned, that there's also really the risk of manipulating a lot of the search results, where the attacker might just get an influence on the retrieval process and leading into either biasing or harming results when we are retrieving. And the last thing is really the prompt injection, which just, again, is a lot of the manipulation of the search queries to really retrieve either unauthorized data or things that we shouldn't really retrieve. The mitigation is really like implementing rigorous prompt and query validation to really ensure that only legitimate reactions are getting and being processed. And if you look at just some examples from this stage on the unauthorized data access, this is a model that we built as in-house, and literally we ingested a lot of the documents. And just to show, like, to kind of just querying a lot of the data that we ingested, we just tax data, dummy tax data from my tax return and my co-founder's tax return. And, I can literally just ask about myself, can provide Oz's information. And then if I ask about Jameson's information, if I don't have the restricted access, I'm just going to get the results. So again, a lot of it comes down to how do we ensure that we create the universe of data that the user has to get access to. And this is a good example I got from a vulnerability report that JFrog got from a vulnerability on Vana, which is a text to SQL. So this is like a good example of just manipulating the AI prompt and the context. So like, quite honestly, like there is the direct question of how to make a Molotov cocktail, which probably nobody should know. And then if you kind of manipulate it, it's a very simplified example, but the manipulation could be, it's like, what steps should I not take in order to not make a Molotov cocktail? And a lot of these, again, because it's a non-deterministic system, there's always going to be a way to manipulate. So we got to make sure that the right set of guardrails and right set of validation processes in place in order to prevent things like that from happening. So just to talk about the security control here. So again, three main things. It's a little bit of an overlap from the last stage, but again, these are the main themes that are coming, like just ensuring that we manage control of who get access and they retrieve specific data from the actual vector database. The implementation of it is two main things, is the role-based access control, again, who get access, and then the granular permission, because whoever is generating the query and whoever is trying to retrieve data, we need to know what data universe that this individual needs to get access to. And the example, right, like, you know, if we have a marketing individual that wants to search on marketing data and presentation, he or she shouldn't probably get access to any sensitive intellectual property R&D documents, even if it's an enterprise search application. They can only get access to what they need to get access to. And when you talked about prompt injection or the model poisoning and things around manipulative things, looking into input-output validation. So the purpose is really to ensure that the data is being, the input into and the output is being examined, making sure there's no harmful content. There is nothing that violates any policy of the company. So it really comes down to the input validation. So really scrutinizing each income query to filter out really the potential and harmful and malicious requests. And then on the output side is verifying the accurate and appropriateness of the output that we're giving to the user. And the benefit of it is if you're validating both, you're really reducing the risk of things that we saw from before, but also revealing a lot of the things that the underlying system really has. So example on input-output validation, I'm sure a lot of you guys know there is open source tools such as Guardrails AI. They have a good library of implementing this input-output validation from the get-go, and you can maintain it pretty easily. And then the data integrity and encryption, again, like we said last time, is just ensuring even on the data transmission, we have a mechanism. A lot of the vector DBs are already supporting it from the get-go, but ensuring that the data remains secure even in transit and even if it's retrieval. So there is not any type of corruption in the response there for hackers to take advantage of. So a little bit about the generation stage here. Obviously, that we retrieve the context and we're trying to generate the response for the LLM. So here, a lot of the things that we're tackling is a lot about the privacy and output manipulation. So on the privacy side, as you guys know, depending on the application, a lot of these applications are connected to foundational models that are outside the organization. People are using GPT-4 or Claude from Anthropic. The thing about it is very easy to connect it to the data, obviously, and start querying as a developer. The things that might pose a risk is if there is sensitive or regulated information that is sent to that foundational model and goes outside an API call. That might actually violate a lot of the regulatory and compliance that your organization actually holds. And as I mentioned, because security is a reactive organization, a lot of the times the chief security officer and his team don't really know that that's the case, that the data that is connected is actually going out to the model. And then obviously these organizations like OpenAI and Anthropic are secured and they're trying their best to be secured, but sending sensitive and regulated information out can either pose a risk on the security of the data that you're holding, as well as maybe a regulatory violation depending on your industry. And then obviously, again, a little bit of overlap is the output manipulation and the bias. Again, we're generating the response. And some organizations and some deployments that we saw really want to have another set of validation when it comes to generating the response. So here again, just to sum it up really quick, so the security controls that we have here is basically the anonymization of data. So ensuring the data is anonymized. It can happen in the ingestion of data into the database, but it can also happen here. The way that we're doing it in a lot of the deployments is actually reducing that private data and then reassemble it after it goes, reducing that privately when it goes to the foundation and reassembling it after it comes back to the LLM. And then reducing the risk of generating any responses that include sensitive information and that can prevent like privacy violations. The validation of just generated content, right? So like scrutinizing the responses, again, like we said in the previous stage, ensuring the integrity and appropriateness of the actual content. And then the output control, and again, safeguard. A lot of the guardrails libraries out there can do it, but the safeguard against inappropriate disclosure and confidential data. And then the auditability, just to add here, the ability to really monitor the inputs and outputs. Again, I know a lot of you are not security professional, but it also helps from understanding what are people querying about, who are people going off topic or kind of asking harmful questions that are completely off topic of what the actual application needs to give. So it's a good practice to actually see it. We saw a bunch of organizations that are much more further in the deployment process, heavily monitoring what their users are doing in order to make sure that they're ready for production without much of a risk on harmful content that comes in and data that is being exfiltrated. So to sum it up, right, just as a security control framework, so really comes down to a few elements that we discussed. So we believe that, again, because the security team is still in the reactive mode, they're still treating this whole GenAI as black box in most cases. It has to be a security by design. It has to come from the development lifecycle. And then really understanding and incorporating security from the very get-go, secured ingestion of data, security and anonymizing that data as development libraries to make sure that you and the development organization can run fast from experimentation to production. Then when it comes to access control, again, we talked about the role-based, we talked about the permissioning on the data and the unification of both to create just the universe of data that the user has to see, whether it's a customer or whether if it's an enterprise search in your organization. And then when it comes to data anonymization, making sure that we don't reveal any type of PII or sensitive information, then the input-output validation as we discussed, and then the proactive, just to add to the proactive evaluation, it's continuously monitoring and testing, and it comes to continuously auditing the prompts, but also considering looking at red teaming and evaluation, model evaluation companies to help you ensure that once you bring this to production, this will be safe and a safe environment for either customers or the organization to use. So again, I think even on the developer side, I think everybody should start in making sure that you guys are involved. There is great organizations that I want to highlight a couple of them. So OWASP is across all of the security stack, not only in AI, and they come up with their top 10 risks for each technology. And this is also applicable, obviously, to large language models. And they have a great summary of a lot of the risks when it comes there. So they bring the top 10. And then there is a group about that's called the Cloud Security Alliance, and they have an AI governance and compliance group. I'm part of it, and each and every one of you can be part of it, and kind of ensuring the policy and the responsible AI deployment is at the forefront. So as AI individuals and developers, I highly encourage you guys to check it out. And that's it. So thank you for the time. And James, my co-founder, and I will be here to just talk to you, and we'd love to learn about your deployments, about your challenges in securing GenAI models. And thank you so much.
Questions? He's right behind.
Thanks for the nice. Hold it close to your mouth. Is it on? Yeah. Thanks for the nice talk. So I wanted to hear your opinion in a little bit more detail when you are actually able to ensure that the RAG system does not see any documents that you don't have access to. And if you're providing grounding in those documents by providing links to them, what is really the role of anonymization of PII when you can just click and see the document?
Yeah, so good question. So I think there's two elements to it. Like one, we need as an organization to rely a lot about these data classification methods. So for example, Microsoft has a great tool called Purview. And a lot of these documents or in the organization, they have to be what we call like AI ready in order to really keep the same security and governance that we have outside the model in the model. So for example, if the document is public, I think that's okay that it's going to be connected to the model and everybody can see it. But if it's restricted and only myself and you can see it, we need to maintain the same level of reading that metadata from the file and ingesting it to the vector embedding to ensure that that universe of data can only be accessible by you or me because we're only accessible to that data. And then to your question on the PII, so sometimes, so what I talked about here is more on a generic approach, but sometimes depending on the business use case, we see people that need to retrieve PII, that need to see in the models like sensitive information. For example, working on a financial co-pilot for an organization, and a lot of this information is just sensitive. But if you're connecting a foundational model that is outside the organization, when you're getting out a lot of this, this PII is just a compliance violation from the get-go, which security is just not aware of. So again, like the ensuring that the access, but also the anonymization has to happen before it goes to the foundational model.
Any other questions? All right, well, let's thank our speaker again. Thank you. Okay, we'll do a quick switch here. Come up. I'll stop sharing. No rush, no rush. All right, so Manasi is our next speaker, and she's a full stack developer here at SAP. And she previously worked at Intel and Link Global, and she got her computer science degree from Carnegie Mellon, really nice school. And today she is going to share how her and the team that she works with built RAG internally. So it's another nice practitioner kind of a review, which is pretty cool, especially if you're still in that kind of a prototypes stage. Are you good? It's okay. Everyone's just staring at you. No pressure. Yeah. Oh.
Okay, I think everyone can hear me now. Hello, everyone. My name is Manasi Joglekar, and like Chris mentioned, I'm a full stack developer at SAP. And today I'm going to be talking about building an enterprise RAG system for the product that I work on, which is called CXAI Toolkit. So I'll be covering what even is CXAI Toolkit. I'll talk a little bit about how we use RAG. I'll cover a high-level architecture design and talk about our trusted AI layer. And then finally, I'll cover some of the lessons that we've learned, as well as some future development that's in the works. So first of all, what is CXAI Toolkit? CXAI Toolkit is SAP's recently released customer experience AI product. It empowers sales, service, and commerce teams to automate routine and time-consuming tasks using generative AI. It has role-specific AI tools that can do stuff like customer communications, record summarization, object detection, image recognition, and more to come. We pull from multiple different data sources. So we pull from SAP data sources, like from Sales Cloud, Service Cloud, and Commerce Cloud, and CDP, which stands for Customer Data Platform. We also pull from Microsoft 365. So we have access to Outlook emails, meeting transcripts, and OneDrive documents. There are a few different ways to access CXAI Toolkit. We have a web app, a browser extension, and soon we will also be embedded in SAP apps like Sales and Service Cloud. And the toolkit also has the option to configure the tools. So admins can create personalized AI tools for their colleagues to use, and they can customize the data sources to leverage their proprietary data sets. So now I want to introduce how CXAI Toolkit uses RAG. And the previous speaker, Oz, kind of covered what RAG is, but just a quick recap, it's a cutting-edge technology that combines the strength of retrieval-based and generative models. So instead of the user just talking to the LLM and like just sending just that question to the LLM, the system will pull relevant documents to the question using a vector database, and then the LLM can use those documents as sources for the answer to the question. And why is RAG important for CXAI Toolkit? It's particularly useful for our intelligent Q&A feature. So we have a Q&A bar in our product where users can ask questions, and then we will use RAG with Microsoft 365 data to generate an answer. We also detect questions in emails in a smart action center that we have, which will then go through the same process using RAG with Microsoft data to generate an answer. And so RAG is really great for us because a lot of the answers are pretty much just contained in the documents that we have from the user's Microsoft accounts, and it helps keep the answers accurate and high quality. So I'm going to show you guys a quick demo video of how this looks in our app. So this is our homepage of the CXAI Toolkit, and this is the Smart Action Center where the questions detected from emails show up. And I'll show you guys how the Q&A works. So we can see in this first email, it's about Kixo software, and there was a question detected. What are the features of the software? So we can hit View Answer, and now CXAI Toolkit will look through any relevant documents. It'll send those to an LLM along with the question, and it'll generate an answer. And I'm just going to give it a second. But yeah, we can see there's a list of like 9 different features of the Kixo software. And it also compares Kixo software to Asana software in the bottom. There's a list of sources. It looks like there's a Word document and an Excel document. So clicking into the Word document, just give it a second to load, we can see it's a feature list of Kixo software containing the same information that we saw in Toolkit. And now clicking into the Excel document, it is a comparison with Asana software. So the Toolkit was able to combine those 2 data sources and give us one natural language answer. So the email also discussed the pricing details of Kixo software. If I want to know some more details about the software, I'm going to type in the Q&A bar, what's the details of the price of Kixo software? And we'll just give that a second to load, but we can see it's describing some different types of plans for the pricing of Kixo software. And once again, there's a list of sources at the bottom, so the users can always check that the answers are accurate. And they can also copy the answer to their clipboard for easy access to use anywhere. I restarted the video. Right, next slide. All right. So here's a high-level architecture design of how our intelligent Q&A works. So we can see how it starts from 2 ways, which I kind of covered in the demo video. Either the user will ask a question in natural language using the Q&A bar, or we will detect questions from the emails received in the Smart Action Center. Then that question will go through our trust layer, which I will cover in the next slide. Then we'll identify the meaning of the question and match with the data sources from Microsoft. So this will be Outlook emails, OneDrive files, including Word, Excel, PowerPoint, and PDF files, as well as meeting transcripts. And coming soon, we're also going to introduce more types of data sources to use. But yeah, this is kind of like the RAG portion where we're comparing the question embedding with the embeddings of the sources that we have, finding the most relevant ones. and including those in the prompt. And then once again, we'll make sure that this goes through our trust layer. And finally, we'll generate the answer from the sources. So zooming into the trusted AI layer, we make sure that when we're crafting the prompt, we're securely retrieving the data, and it's grounded in the documents that we have. We make sure to obfuscate any personal data, and this also kind of touches upon what Oz talked about. But when there are any like names, emails, SSNs, we actually do use Presidio, which Oz talked about as well, to obfuscate that. So if you have like a name, that'll get obfuscated into like bracket person1 close bracket. And then we use a content safety checker to prevent any bias. And then finally, the prompt goes through an LLM, and we have a zero data retention policy for this. So we don't allow the users currently to like respond to what the LLM says. We just do like single question, single answer. And then when we get the response, we make sure everything is audit logged, and we also have a human in the loop so that over time we can improve the Q&A system. So I want to talk about some of the lessons that we've learned, specifically related to obfuscation and entity detection. So one thing that we learned is that casing is actually really important for certain entities. So if we have the name Max and it's capitalized, we realize that Presidio will obfuscate that into person1, but if you have lowercase max, like maybe the user is just typing quickly and they don't capitalize it, then that actually doesn't get obfuscated. And then it's hard for the LLM to know that Max is person1 when it's obfuscated sometimes, but not all the time. So the way that we fixed this was extracting the entities from the context and then applying a case-insensitive replacement in the query. So we always correct like lowercase max to uppercase max if we found it in the relevant context. And then that becomes a lot easier for the LLM to match the two people. Another issue that we found was that the LLM might slightly change the masked entity format in the response. So in our case, the masked entities had like a certain type of bracket, like the arrow brackets, and it just changed the types of brackets. So this one we were able to fix with some prompt engineering. We just instructed the LLM to keep the original format in the prompt, and that seemed to fix it for us. And then lastly, another issue is that the user might type person names differently or introduce typos. And this kind of brought like a similar issue as the first one, where like maybe in the context, it's all spelled a certain way and it all gets obfuscated as person1. But then when the user's typing a question, they introduce a typo and then it gets obfuscated as person2. Then the LLM doesn't know that person1 and person2 are the same. So the way that we fixed this was we extracted the entities from the context and we used max edit distance to correct the question. Yeah. So some of the future development that we're working on currently is we want to work on collecting user feedback to improve the quality of our Q&A answers. We're also looking into streaming the LLM answers to improve the user experience. And that's a big one. As you guys saw in our demo, it kind of took a few seconds for the answer to come, especially when it's like a really long answer with a lot of content. And then the user is kind of just left waiting there. So streaming shows that, something's going on. And then I also touched upon this previously briefly, but we want to add more types of data sources for our intelligent Q&A answers. So we want more SAP data, such as Cloud for Customer V1 tickets and Service Cloud V2 cases. And we're also looking into adding custom data sources so that customers can leverage their proprietary data sets for the answers. Yeah, thanks everyone. And are there any questions?
Yeah, great presentation. Thank you. So in one of the slides, I saw the partner LLMs, and then you're also using your own data sources and data set. So what is the chain of events? So when a user asks a question, first, like your algorithm finds the data in your own sources and then feeds that to LLM? Or is it like a combination of data at the same time, or like what exactly happens then?
I would say it's the former. So we first find the relevant data and then we send it to the models.
To the
yeah.
LLM,
Yeah,
and
to
then
the
you
LLM.
get the response from
Yeah,
it.
yeah.
Yeah, very interesting approach. Thank you.
Hi, thank you for the presentation. It's very good. So I have two questions. So one is on the secure data retrieval on one of the boxes that you have. Like what are you doing there? And the second thing, I think you touched on this slide about streaming data, because it sounds like you're doing name entity recognition and a lot of things. So there are a lot of steps. So like how the performance look like?
Yeah. So for the secure data retrieval, I think it's really just about making sure that we make sure we have like keys and like rotating the keys for like when we're fetching the data, like so like when we have the embeddings, and then also when we like are fetching the actual content of it. So we're just making sure that we're following like the best practices here for just like accessing that data and making sure that just some random person on the internet can't like access it. But I'm not like an expert on this part, so if you would like to connect further on that, I can I can connect with you afterwards. And there's some other people that worked on this that know a little bit more about it than I do. So yeah, would be happy to connect after for that. And then for your second question, the named entity recognition and obfuscation. So yeah, that was something that we had to like iterate on a little bit to make sure it wasn't taking too long. But I think like, so after using Presidio, and then we're only kind of doing like a few rounds of the like corrections, I guess. So we haven't really noticed a big slowdown so far from doing the types of corrections that we are, but I imagine, potentially, I guess there's a chance that it might get worse with like more and more data. But yeah, once again, happy to connect afterwards because there are also some other people that worked on this a little bit more than I did. Yeah.
Hi, great presentation. I have two questions. One tactical question is, when you're retrieving the chunks or those, and how long back you go? Do you go by percentage saying, okay, I'll go to 90% cosine similarity, or are you saying I'll only take the last 10 chunks or the best 10 chunks?
So when you say like 90% cosine, so I'm pretty sure
probability of match, you would get some kind of percentage, right?
Oh, so you're saying, okay, I think I understand. So you're saying are we picking like the best ones, like regardless of the number of chunks, or just the best 10 chunks? So it's both. So we are both, so we first fetch like the top K chunks, but then we also check whether like what the actual similarity score is. And if it's too low, then we don't consider.
Yeah, so I'm asking what is the K? Like, is it like 90, 95? Like, where do you stop? And what is the percentage? That's the question. I understand it is.
So I guess I'm not exactly sure like what those actual numbers are right now because we have like iterated over them for a while and I haven't really touched that part of the code in some time. But we aren't sending like, it's definitely not like 90, it's like a lower amount because it does take, we don't want to send like a bunch of data to the LLM because we noticed that that was causing like a slowdown. Also like just fetching the content from like Blob Store for like a huge amount of data like takes a lot of time. Especially if it's like not cached, like if someone hasn't accessed it in a long time. So we don't send like a ton of data. And I believe that it is around like 90% for the cosine similarity. Yeah.
The second question is, when you do affixes, when you remove the named entities in a chunk or in a document like a driver's license, you'd find two names, name of the person, and sometimes you'll find the name of the signatory, or and if you obfuscate it, how do you like contextually retrieve the right answer?
Like I'm trying to say, hey, give me context information about Mr. X, but you obscured the information in the first place. And there are two named persons, which have, how do you retrieve that?
So are you trying to say that the two names are like the same name or
Are
two
pretty
different
close
names?
by. Those names are pretty close by. It might come in a same chunk, but you are removing it, right? You're saying it is person one, person two.
Mm-hmm.
But when I'm asking a query, I'm naming the person, right?
Mm-hmm.
How do you retrace back?
Yeah, so then so if in the context it gets obfuscated as person one, then the question, if it uses the same, if it has the same like name, it'll also get obfuscated as person one. So then the LLM can see that like person one matches person one in the question and the context, and then it can answer that. And then when we get the answer back, we'll see like we mapped person one to this name. So then we'll return that in the response. So the user won't see like any obfuscation. They'll just see the data that they expect.
Any other questions? Oh.
It's a great technology showcase. I'm wondering if you have done any user experience study, especially its impact on the workforce. Will that make employees very lazy and rely on the computer system just to generate whatsoever? Does it really improve the customer service quality?
I couldn't hear like the last part of your question there. So I think what I heard is that, will this make the customer service workers lazy? I feel like it won't make them lazy. I think it's more about letting them focus on the real problems of like how to actually solve problems and like the interactions with the customer. So if a customer is asking, is running into an issue and a service agent has to like spend a long time looking for the answer, it's like that's probably not what they should be working on, right? If the answer is like available easily in a different case, they can focus more on that interaction, and I'm sure it'll help solve these cases quicker and improve customer satisfaction.
We're all looking to be lazy.
Yeah, I have one last question. I wonder if you evaluate the accuracy and control hallucination during production, and how do you do that? Because I know like each LM has different bias, right?
Mm-hmm. So let me just repeat the question, make sure I understood. So you're asking how we're reducing hallucination in production because each LLM has like different, is kind of different. Yeah, so I guess we're currently using GPT, I guess, just for reference. And I feel like most of the questions that the users are asking are like pretty specific to like the types of, like they end up being pretty specific and not just like stuff that you can find on the internet. And they end up being pretty like closely matched to the sources that we have. Oh, also, I forgot to say, but if there's no sources, so we first do RAG. If there's like no sources that are close to the question, then we don't give an answer, because we feel like people shouldn't be using this just for like general question answering, and we want this to be like very specific to the types of like like private data that people are using. So yeah, if we don't have sources, we don't even send it to the LLM, because we know we're not going to get something that is what the user is expecting, really.
Yeah, thank you. So to control that output, you do it through prompt engineering, or how do you tell?
Yeah, so we do have something, we did do some prompt engineering. So we tell the LLM to like only use the sources that we provided, which definitely helped a lot when we were going through it, or like when we were developing this. And yeah, so if we do find documents that are like at that threshold, like around 90% similarity, then I think it's pretty easy for the LLM to like just end up using those sources, because the question is like so related to them. We haven't really seen that much hallucination in production.
Any other questions? All right, thank you so much. And we're going to go down a little bit different path. Frank, you ready? Of course not. He's trying to get his power. So Frank actually works with me at Zillis. He's our head of AI and ML. And he is going to continue down the conversation of RAG, but take a little bit of a different approach and talk about multimodal RAG and give everybody a little bit of a history lesson, which I think is going to give us a lot more context on, how this actually works. You want this or this?
All right. Just throw that in pocket. All right. Back to you.
Are you sure? On the Zoom?
Yeah. All right. Sorry about the tech issues there, but yeah. First off, I want to thank everybody here for coming out and making the trek over to the Unstructured Data Meetup here. I also want to thank our previous two speakers, as well as SAP, our gracious hosts, for actually providing this venue. Today, I want to talk about a topic that is actually very near and dear to my heart, and that is multimodal embeddings. But before we dive too deep into it, I want to talk first about the history of embeddings. How did we get to where we are today? Some of the modern ways that we actually generate embeddings for a single modality, and then we're actually going to talk about multimodality. And I think hopefully by the end of it, you'll have a better understanding for how vectors and how embeddings fit into the broader unstructured data space, and at the same time, maybe a sneak peek as to what we can expect on here. What's that? Is your oh, echoing a little bit. You want me to go into mute or? Yeah, just mute. There we go. All right. Hopefully no more interruptions now. But yeah, so hopefully it'll give you guys a good understanding of how embeddings fit into the broader unstructured data space. So I'm just gonna get right into it. My name is Frank. Pleasure to be here to present to you guys. I'm currently head of AI and ML here at Zillis. For those of you that aren't aware, Zillis, we are the creators of Milvus, which by many metrics, as was discussed a little bit before, is the world's most popular open source vector database. Feel free to connect with me, right? So that's my email, LinkedIn, and Twitter. My figurative door is always open. So always feel free to reach out anytime, especially if you have any questions after this talk related to some of the content that I presented here. So a quick refresher, I think, before we dive into all of this material. And the key thing that I want to emphasize is that vectors really help unlock unstructured data. Right? What is a vector database for? Most of us recognize vector databases as something, a component of RAG or a component of semantic text search. But I think it goes way beyond that. And this is a recurring theme that I'll talk about throughout this presentation. And that is that really any type of document or any type of unstructured data can be represented as embeddings, as vectors, stored inside of a vector database, and you can perform semantic search over it, you can do RAG, you can do many, many different applications. This single workflow unlocks a variety of different analytics and unlocks a variety of different ways of being able to see your unstructured data in a way that you otherwise wouldn't be able to if you just had labels or something along those lines. Generally, you will have embedding models. These embedding models are neural networks, not always. Sometimes they are, let's say, these handcrafted algorithms or handcrafted features. And again, I'll get into that a little bit more later on in this presentation. The second thing that I want to talk about in this quick refresher is the idea that embedding models are the workhorses of AI applications. Now, I know many of you here are probably familiar, you probably know that Llama 3.1 was just released earlier today. So going down a trip into memory lane, I wanted to compare a very, very popular embedding model, that's All-Mini-LM L6 V2 with Llama 2 at its heyday. And you can actually see there's a pretty substantial difference, probably about a 7 or 8x difference in the number of downloads within a single month on Hugging Face. And I think there's many, many reasons why that can be, right? Embedding models, sure, they're great for RAG, but they're also great for many, many other applications that are being put into production today. Semantic text search, classification, clustering, so on and so forth. So it's really, really important to be able to understand that embedding models, especially small, compact embedding models, that give you a great representation of the data, the underlying data itself, those are really, really important in a lot of unstructured data and AI applications today. So moving forward, right, I'm going to talk a little bit about the history of embeddings, and hopefully this gives you a better idea for how we got to where we are today and where we're going to be going in the future, right? Why is it relevant? Why are embeddings relevant for us? And why are they so important for us to be able to understand all these different pieces of unstructured data? So back in the day, we had what are called these handcrafted algorithms or handcrafted features. I see some nods in the audience. In particular, over here on the left, this is the scale invariant feature transform. And essentially what it is it's finding key point descriptors inside of your image, potentially inside video as well. That's a topic I won't get into. And if you think about it, if I take the top 10 descriptors for that image, I concatenate them into a vector. Now all of a sudden I have a representation of that image that is 1,280 dimension or a 1,280 dimensional rank 1 tensor. And that forms the foundation for embeddings and vectors today. Same thing goes for TF-IDF, right? With TF-IDF, you can actually turn a document, if you have a document and you have a vocabulary or a dictionary, you can actually turn that into a sparse vector and you can do searches just based on that vector itself. And the same thing goes for the Harris corner detector. Now, typically there's no feature output or descriptor from the corner detector, but what you can do is you can take the XY axis, you can take the intensity, and also probably the angle of that corner as well, and represent that as, let's say, a 4-dimensional feature vector. There's many, many different ways of being able to extract features, extract vectors from different pieces of unstructured data. This is very, very long ago. So, TF-IDF was in the 70s, 80s. Harris corner detector, I think, was 1988 when it was released. SIFT is, 1999, just a little bit older than I am, actually. Excuse me, I'm a little bit older than SIFT is, but I wish SIFT was a little bit older than I was. But again, these are very, very old ways of getting features, of getting embeddings from our unstructured data. And if we fast forward over to 2012, right? So before 2012, we also had the ImageNet competition, and actually a lot of the winning entries were based on bag of words feature vectors using SIFT. And we fast forward to 2012. Now all of a sudden we have these really, really powerful neural networks, these ConvNets. And what they really do is they take advantage of the idea that in visual applications, in vision, in images and video, you have spatial locality. So they use convolutions. They at many, many different hierarchies. And at the very end, they do some sort of pooling or some sort of fully connected layer, some sort of multi-layer perceptron. And the penultimate layer is typically, back then, was the embedding that you'd use to represent the images. And many people, that was really when many people, not just in academia, but definitely in the industry as well, they recognize the power of embeddings. They recognize the power of vectors and some of the different things I could do. Here on the left, I actually have pictures of different types of food. I know we're a little bit short on food here. I think there should be a little bit more coming. So, the first row you see fries, and the second row you see that looks like Korean barbecue. And what you see in the middle and on the right is actually the most relevant retrieved results in a vector database. I think this shows what a vector database and what these embeddings are capable of. They're capable of simply giving you the most relevant content, not based on labels or human annotations, but based on the actual content of the unstructured data itself. Now, if we move forward, there's also RNNs. I'm going to talk about this very, very briefly, but really they are the OG language model. So you see that blue box there? That is an RNN cell, and the idea is that we continue to feed an input, get an output from that cell, and there's a hidden state represented by A of t that continually gets updated at every timestamp. I'm not going to go too much into the details of RNNs, but that essentially is our embedding for every single timestamp, or for all tokens up to time t, right, or up to step t. So that brings me a little bit more to modern embedding models, and this is going to tie in very, very closely with multimodal embeddings as well, right? So I talked about in 2012 how there was a deep learning boom, how ConvNets became very, very popular. Today, in 2017, there's a paper, Attention All You Need, that introduced the concept of encoder-decoder architectures and self-attention. And I think I'm not going to talk too much about this. There's a lot of great material out there for you if you want to know a little bit more about the transformer architecture. In particular, I recommend Jay Almar's Illustrated Transformer. I imagine some of you here in the audience have probably seen that blog post, actually. The key idea behind the attention mechanism is that you now can pre-train these very, very large models over large quantities of data. And that's really what BERT showed us. So with BERT, with NextSense prediction, and with mass language modeling, what you can do is you can actually pre-train this large transformer, and then you can fine-tune it on your downstream task. So for example, in the case that we see on the right, that is actually sentence BERT or sentence transformers. We're taking 2 pre-trained BERTs, pooling the results, taking the cosine similarity, and we're fine-tuning it based off of that, right? So what we've seen here is really a shift in the way that we're doing things. Rather than taking a lot of labeled data, doing the training that way, now we do pre-training on tons of data with a self-supervised objective, and then we fine-tune it, same way that a lot of LLMs are trained today. Move forward to the visual modalities, right? We see that the vision transformer, they actually unified architectures for language and for vision as well. Now we can use the same backbone, or we can use the same model architecture for many, many different modalities. In the case of VIT, what we're doing is we're actually taking an image and we're turning it into individual tokens by patchifying it. So a 256 by 256 image, it could be turned into 8 by 8 patches or 16 by 16 patches, and each of those get run through an encoder represented as an embedding, similar as you would, let's say, text or something, some other sequential sort of data as well. So that brings me to a point that I really want to emphasize in this presentation, which is that we see a lot of great ways of vectorizing natural language, text, and images, and potentially other forms of visual data as well. But vectors are for way more than that. They're for way more than that. The first example that I want to give is molecules, molecular structures. Probably not the first thing that comes to mind when you think about vectorization and when you think about vector databases, but it's one of the great ways that you can do it. So the example that I show up here, this is actually, it's topological or Morgan fingerprints. The idea is that we encode the atoms, the bonds, the functional groups, and what they actually do, what this particular molecule does, into a low dimensional, usually a binary vector, maybe something like 64, 32, or 128 dimensions. And that is a good representation of our molecule. Things like AI-powered drug discovery and many other applications that leverage molecules or molecular structures use these types of fingerprints to build all sorts of different applications. The next example I want to talk about is audio. This, I think, is Wave2Vec 2.0, is a combination of, it uses a very, very similar architecture as the vision transformer. It uses a convolutional encoder to actually encode these latent patch representations. And then it uses a transformer as the backbone to, as the objective, or as the backbone for the ultimate objective function. Graphs are another one, right? If you have a graph of, let's say, relationships between different nodes, by turning that graph into an adjacency matrix and using an algorithm like FastRP or something along those lines, one of the things that you can do is you can represent each of the nodes in that graph based on its connectivity. Now, this is great for things like fraud detection. It's great for things like logistics, for finding, let's say, different potential suppliers in a very, very complex supply chain. Many applications along that line as well. And the final one that I want to leave you off with today is actually time series data. This one, I think, is called TS2Vec, and it uses this, it takes this hierarchical representation and actually waveforms that are part of or that are very, very similar in the same area temporally as other input chunks or other input splits of that same waveform. You try to minimize the distance between those two embeddings, and that's really what TS2Vec does. It does that at different hierarchies as well. So I give you 4 examples of modalities besides for images and text that you can store in a vector database, as well as some of the different applications that you can use those different modalities for. And I hope that sort of juggles your mind into thinking more than just, text-based RAG, more than just taking, our documents, our markdown files, our Word files, or our PDFs, chunking them, storing them in a vector database, and using that vector database for retrieval. There's so much more that you can do. I think the possibilities for unstructured data and vector databases really are limitless. And I encourage everyone out there to just go think about it and play around with Milvus and or Zilliz. So that really brings me to, I guess, the meat of my presentation. How am I doing on time? Okay. So that brings me to the meat of my presentation. I'm going to talk about multimodal embeddings and also multimodal RAG. hopefully, something a little bit closer to what a lot of folks here are familiar with. I'm gonna talk first about CLIP, or a lot of CLIP-like models. So what these are doing is they take text, they take a text encoder, they take an image encoder, and they actually use I just looked up the name of this loss function. I actually forgot it already. It is a form of contrastive learning. I think it's called, it's not n squared, it's multi-pair. I think it's like multi-pair n loss or something like that. So it is a form of contrastive learning. And what you're trying to do is you're trying to, within the entire batch, you want to minimize the distance between the embeddings along the diagonal, and you want to maximize the distance for all other pairs, right? This one is called ImageBind. It also uses multiple forms of contrastive learning, I think in this case. And I'm not going to dive too deep into this one, but this was released last year by Meta. And what it's doing is it's tying 6 different modalities together using images and using video. And I think this is really, really interesting. It shows that we can actually have many, many different types or many, many different modalities of data and have them all embedded into the same exact space and retrieve all data based on that space as well. So for example, if I have audio of a crackle of a fire and I retrieve the most relevant visual data, depth images, and text, they are indeed very, very relevant to our input audio. I can do the same thing for a baby cooing and for many other pieces or types of audio as well. And probably the last or the second to last thing that I want to leave off with is the idea that large language models are also going multimodal. So this is actually from the Llama 3.1 technical report. This is so what was released today, it doesn't support all these modalities yet, but I think it shows where LLMs are going. They're going to be able to support images and video and audio and potentially many other modalities of data natively directly within as inputs at the very minimum into the LLM. And I'm not going to walk through the full architecture here, but I just want to show you that indeed it's going to be able to support image inputs, video inputs, text inputs, as well as speech and potentially non-speech audio inputs as well. So this is really, really powerful. These LLMs are becoming very, very powerful, and we need more than just text-based RAG, right? We need more than just vanilla RAG. So I'm sure many of you are familiar with this particular model and this particular way of doing things. It's no longer enough. We need multimodal RAG. And you'll see that actually multimodal RAG, the architecture is not very different. The architecture is not very different. We use, instead of a text embedding model, now we use a multimodal embedding model. We embed all of these different pieces of unstructured data, ideally into the same space, store them inside of Milvus, probably in the same collection. And then when a search or a query or a prompt comes in, we vectorize that using the same model, and then we get the same reliable answers that we all know and love. So this is multimodal RAG. I like to call it RAG 2.0. Different people call it different things, but we'll leave it at that. So I want to leave off with a very, very quick demo of multimodal RAG in action. And I hope this is something that's going to be really interesting to everybody here. What I'm going to do, I talked about how Llama 3.1 eventually, not the release today, but eventually it's going to be able to support many different modalities, images, video, and audio. And what I want to do is I'm going to take a video. I'm going to take, in this case, it's Google I/O's pre-show. Did any of you actually attend that, or any of you see that? Okay, we have 1 or 2 hands in the audience. So I'm going to run through it very quickly what happened in here. Basically, in the pre-show, this musician, he crawls out of this big mug. He falls back into it first. Then he's going to crawl back out. And he does sort of this performance for a lot of the folks that are at Google I/O using Google's, I think it's called like Music FX DJ or something along those lines, right? So this is what the video looks like. And I want to be able to ask and answer questions related to this video. These questions are not in the documents are not in the form of text, but in this case, the document is the video itself. I'm going to run through a demo of potentially how we can do that. So we're first going to use PyMilvus. So I actually have all these dependencies installed. We're going to make this notebook available to everybody sort of after this presentation is done. So we're going to use PyMilvus. We're going to use Milvus as the underlying vector database. Radiant is a library actually that I created, and it's designed specifically to work with multimodal embedding models. And then we're going to use Hugging Faces transformers as well. We're actually going to use Chameleon 7B. So because the multimodal portions of Llama 3.1 or 3.2, whenever it's going to be released, because they are not out yet, we're going to use a slightly older model. We're going to also from Meta AI called Chameleon. Anybody heard of it or anybody use it yet? Chameleon? Chameleon actually came out probably about a month or two ago, not Llama 3. So it's not Llama 3.1. It's called Chameleon. I can actually Google it here. So yeah, the paper actually came out in May, and the idea behind Chameleon is that it natively takes images and text as input, right? So we're going to use this. So we're going to tie all that together, right? So what I'm going to do first is I'm actually going to I'll just describe what this code is doing. I'm not going to walk you through every bit and piece of it. I'm taking this particular YouTube video at this link, which is the Google I/O pre-show, right? I'm going to download it, and I'm going to do what I call demuxing. So that's going to split the visual and the audio portions of this particular video. It's going to take samples every 5 seconds, and then it's going to store both the image and audio inside of a vector database after vectorizing it using ImageBind, using this model that I talked about right here, using this one. And what that gives us is now we can, instead of, when we query the vector database, instead of requiring, let's say, an image and a piece of audio to query it, we can just query everything. We can store all these different pieces of unstructured data in the same collection, find the most relevant results just using text. So I'm tying all three of these modalities together. Everything's stored in a single column, and it just makes it very, very easy to go from vanilla RAG to multimodal RAG, right? So when I run this workflow, it's actually going to, it actually might take a little bit of time. So let me actually restart the kernel here just to make sure I have a clean slate. So this is going to take a little bit of time. I'm going to describe what's going on in the rest of the code here as well. After that, I build a workflow to do the searches too. So the searches in this case, they also use ImageBind. They're going to use the text modality. And they also are going to, once they have vectorized the text, they're also going to query Milvus. I'm going to use that vector, I'm going to query Milvus to get my most relevant results. After that, we're going to specify a prompt. In this case, my prompt is going to be what was weird about the coffee mug. And the coffee mug really only appears, I'm just going to run through the video really, real quick. The coffee mug really only appears at the beginning of the video. So you see probably about right here when the musician crawls out of it. And hopefully it retrieves some frames, some visual data that is most relevant to this particular prompt. And I think once this is done, we'll get there. After that, I'm just going to show that image. I'm just going to show the image that was retrieved, and hopefully it'll give you guys an idea of how this model is tying everything together. From that point forward, we're actually going to go to the generation step. Again, we're going to use Chameleon 7B in this case. It is a small model. Now, I actually can't, so this will run on my computer, but will run very, very slowly. So I don't have that much RAM. I also don't have a GPU. So again, it will run, but I strongly encourage you, if you're on a Mac, to have at least 64 gigabytes of RAM. If you're not on Mac, if you're on Linux, I'm not sure about Windows, I haven't tested Windows. If you're on Linux, you can actually specify a D type of bfloat16. Don't specify float16 because a lot of Intel CPUs, they don't have that kernel implemented in Torch. So specify bfloat16 and you're going to be able to reduce the memory requirements. So let's see, hopefully this is done. I can actually walk you through what's going on here as well, actually. So it's extracting the video, it's downloading the video. In this case, I used YTDLP. And you can actually see that now it's splitting the video into little bits and pieces, and it's doing the vectorization really just on the spot. So we're going to wait for that to be done. I'm actually not sure how long it's going to take. So while that runs, I can take a question or two.
So Frank, you're not cheating, right, and using a transcript?
I'm not cheating using a transcript. This is actually just running right now locally in my laptop. You can actually see just based on this star symbol right here.
Is encoding the video is basically like 60 frames per second. Is encoding videos and images the same thing, or like they use different approaches?
Yeah, so Encoding video, images and videos, it depends on the model that you're using. So in this case, what I'm doing is I'm actually splitting the video into frames and 5-second audio snippets. So every 5 seconds, I'm taking a single frame, and I'm also taking audio snippets that are 5 seconds long as well. Yeah, but there are also ways that you can vectorize videos themselves straight. For long form videos, I don't recommend you do that. The reason is because you just end up losing way too much. And there's also possibly some memory limitations as well. A lot of these video models are based on transformers these days too, and you'll just run out of memory very, very quickly. Take another question as well while this is running.
Yeah, so I have a question. So I'm kind of curious. So you tag in image, audio, and then text.
That's right.
And then you search by text.
That's right.
So does that mean that you convert the video and audio into text at some point with the embedding, or?
The video and audio, I'm going to go back to this slide right here. Go back to this one right here. Or here, I'll actually use this one. The video and audio, irrespective of what the data is, it runs through the exact same multimodal model, and that all gets turned into vectors. So the video will first get turned into images and audio, two separate streams. Those streams, each of the elements in those streams will get turned into vectors. So in this case, you'll probably have something like several hundred or several thousands of vectors that are now in that vector database. Half of those vectors will correspond to image data. Half of those vectors will correspond to audio data. And then when text comes in, we vectorize that text as well. And then we search just that collection. We search that collection inside of Milvus for the most relevant results.
Hey, Frank.
Yeah,
hi.
Go ahead.
Love the presentation. Thank you. So a lot of the modalities you mentioned have specialized data stores to search and query them.
Yep.
In your experience, like, in what cases are vectors a good destination to optimize, and in which cases should someone go for, a graph store or a time series store or something like that?
Yeah, I think if you want to search exact values, if you want to do exact searches, right, for a time series database or for a graph database or for a relational database, they're all based on the concept of, exact searches. What a vector database is great at is understanding the semantics, understanding the content of your data. So the analogy that I like to use is, we communicate in English, right? Computers, they don't communicate in English. Natural language is actually very, very unnatural. Computers, they communicate with numbers. They communicate with embeddings. In particular, a model is the language that they speak, and the vectors and the embeddings, those are the words that they generate, right? Those are the phrases or the paragraphs that they generate. I think that's the analogy that I like to use, and I think that sort of just goes to show you why I think we need vector databases for unstructured data rather than just vanilla RAG.
Thank you. Great presentation.
Yeah.
If we want to develop a similar large language models or a different language, how would it be different? Like, do we need to build them from scratch, or can we use some of the models? Because once the language is converted into ones and zeros, it does not matter. So my question is, can some of the work be used for some other language?
Can some of the embeddings be used for other languages as well? It depends on what the model or what the embedding model is trained on. And a lot of embedding models these days are multilingual. So, they can do German, Japanese, and English as well, obviously. As long as it is in that training data, generally you will be able to use that embedding model for other languages as well. It really, a lot just depends on the data at the end of the day.
So we are making an assumption that the models that are trained on have already used the language as a part of the training.
That's right. That's right. That's right. Now, there are instances, and we're getting a little bit deeper, there are instances where most of the models, let's say, 80% of the training data is on English and only 20% is on German. And let's say there's something, there's like a very, very niche topic that's talked about in English, and you want to look at the embeddings, or you want the large language model to understand that topic in German as well. Generally, actually, in many cases, you actually won't need to retrain on that specific topic in German. So you will actually find that the model actually is able to generalize well to other languages, as long as there is as long as there's a mixture of languages in some of the training data, if that makes sense.
Yep, thank you.
Yep.
The other question is, for specific fields like healthcare or financial or particular industry vertical, does it matter that we need to train it on dedicated documents that belong to that particular vertical? Do we add any additional value by doing that?
Oh yeah, absolutely. So if you've ever read a patent, or if you've read, let's say, like a legal review or a case study, you know that the language in those sort of, I'll call them sort of submodalities. In those submodalities, it's very, very different. And I think there's a lot of value. So look, at the end of the day, RAG is not a framework. There's no way of saying, oh, I'm going to take a framework or a single framework and I'm just going to be able to use it just like that. RAG really is it's an engineering problem. It's an engineering challenge. There's many, many different things and many different aspects of your input data that you're going to want to optimize. And the first thing that you do optimize is the embedding model itself. So if you have a lot of financial data, or if you have a lot of legal documents, you want to have an embedding model that is tailored to those to really extract the maximum performance out of your semantic search or out of your RAG system.
Do you want to keep going, or do you want more questions?
Yeah, we can keep going. I realize that
we have plenty of questions.
Oh, okay. Yeah. All right. We'll start with you, and then we'll come to you up front here. Yeah.
Can you hear me?
Yep.
Yeah. Hey, Frank, this is really great. Thanks so much. So I had a question about multimodality, right? So
Yep.
before you answered that, you're not converting media like video or images into text. You're actually generating embeddings for the media separately.
That's right.
But how do these embedding models, reduce multimedia into the same dimensionality? Because if you think about it, video is a very different media source to text. But for embeddings and similarity and RAG to work, it kind of has to be in the same dimension, right? So how can you explain a little bit on how that works?
Yeah. So an audience member somewhere in the general direction mentioned the idea of contrastive loss or contrastive learning. The idea is that you have pairs of data in different modalities that are connected to each other. Now, they're not necessarily equal. I mean, an image is worth 1,000 words, and there's many, many different ways to express an image, for example, that will be correct. But the reason why I wanted to highlight this slide is this is, in general, how things work for modalities beyond text and images as well. So there's some form of contrastive learning that is applied. For example, if you can find a way to connect images and 1D, thermal data, or you can find a way to connect text and audio snippets together, you train all of those modalities together contrastively. You have multiple modality trunks, and all of those trunks embed the data into the exact same embedding space, right? So that's really what we're looking at here. It's just contrastive learning at large, massive scale with high quality data. That's going to give you a good multimodal embedding model.
Got it. So just to follow up, right? So the data used to train such embedding models have to be multimodal in nature themselves. So they need to be image and text or video and sound, etc.
That's right. That's right. So if we look at ImageBind here, they actually take many separate data sets. They combine some of those data sets. They start with clip, take many separate data sets, and bind all of that's why it's called ImageBind. Bind all of those to the visual modality. Yep. I think we had a question up front as well. Yeah, go ahead.
So I was almost going to say that took my question, but mine is very, very similar in that since all of these different modalities are ending up in, say, the same embedding space, is there any sense in which certain modalities are better represented than others in that space? Right? Like, if you're binding, say, images and text together, does it matter, how descriptive that text is relative to the image? Is there any sense in which the data that it's actually trained on affects the model down the road?
That's a great point. You'll actually see, so I have to admit for this particular demo, so even though this is still running, I did not realize it would take this long, I apologize. For this particular demo, I cheated a little bit. I used a very, very short prompt. So the prompt was, what was weird about the coffee mug? And you'll actually see that for ImageBind, it generally doesn't do very, very well with long prompts because, well, a lot of the data that clip was trained on, if you pair those images and the text modality together, you're not going to get someone to write an essay about a specific image. Usually there's just a very short description. or there's a very short follow-on related to the image that helps you understand more about what was in there. So the quality of your data, and again, it goes back to the whole, it goes back to the whole idea of, you know, where modern ML is today. It's all about data, data, data. So if you have really, really long form images, long form text that describe images, you're going to get much, much better results with longer prompts as well. And the same thing goes for the audio modality. So for this particular example, Mark, who is the musician up here, I mean, he goes wild. He's basically he's basically magic mushrooms in human form. So, you know, he actually speaks a lot on stage. And ImageBind is unable to capture that because it wasn't trained on that, right? There's no substep in there that is doing audio to text and then text to embedding. It is taking the audio and embedding it directly. So that's why if we come back here and we look at this, right, here, it's not really any spoken languages happening. It's a crackle of fire. It's actual audio. Here, you know, it's a baby cooing or a car horn or a ship horn or, you know, the sounds of traffic or something like that, right? So that is really what, at the end of the day, it's still very, very dependent on the data. Many of these multimodal models are still extremely limited. I do want to warn you. And there's a lot of work to be done in this whole space, but I think the next couple of years, we are going to see a lot of work being done here to tie many, many different modalities together. Great question.
I have kind of a follow-up question to that. It's very cool that you can now do these cross-modal searches, right? But in essence, you can also do the same thing using a large multimodal model to generate a very detailed caption of the image or the video, right? That will actually contain a lot more detail than the clip-like embeddings. In the end, it comes down to evaluation, right? To accuracy and like how good is your retrieval actually. So can you speak a little bit to the pros and cons of these two approaches in terms of quality?
Yeah, I think there's two factors here. So there's always a trade-off between accuracy and then cost plus performance. I'll lump those two together. If you actually take a video or an image and you pass that to an LLM and you say, hey, generate a caption for this image, generate a very detailed caption for this image, sure, it might be able to do so, but it's going to cost you a lot of money for that very specific image. And B, it's going to take time to generate that particular prompt as well. When I think about retrieval problems, when a lot of organizations out there or companies out there, they think about retrieval problems, they don't think about it from the perspective of, hey, let me get the maximum accuracy. They think about it from the perspective of how can I get the maximum accuracy in the allotted time or in the amount of compute that I have. And that is really when you want to use embeddings. Embeddings are really a first stage. So, you know, if you're familiar with the idea of re-ranking, embeddings really are a first stage way of being able to retrieve the most relevant data. If you want to add on or if you want to tack on to that, then hey, that's when you take your data and you run it through an LLM or you run it through a re-ranker or a more powerful model basically. Yeah.
Right. So you think that captions are going to be more detailed and accurate?
Captions are definitely going to be more detailed and accurate, especially given the current state of multimodal embedding models. I think ImageBind is one of the more impressive ones today, and it's a year old, right? It's a year old, and it uses just a lot of open data sets. There's not a lot of proprietary data sets that were used in ImageBind. Great question.
Thanks.
I know there's a couple more. I'll be out back actually, so feel free to just come up and talk to me. I want to run through the rest of this first. I'll be very, very quick, I promise. So we're going to do the search here. So now there's a bunch of warnings here, but don't worry about them. What we've done is we've inserted 258 image embeddings. And if we actually scroll down here, we've also inserted 258 audio embeddings, both into the same collection, right? These embeddings are the same dimensionality, they're in the same column, and we query them the same way. So now I'm going to do the search. I'm building the search workflow, and then here I'm taking the prompt, I'm running it through a text encoder. The text encoder comes from its particular trunk of ImageBind. So I'm going to run that, and then I'm going to take a look at the results of the top one entity. So I'm only giving Chameleon one sort of entity from my vector database. And we can actually see what that is, so we can display it here. So again, this is the most relevant retrieved content from this video for the prompt. What was weird about the coffee mug? Okay. And yeah, I mean, it's a coffee mug and it's pretty weird. Yeah, it's very, very funky. It's very unusual unless you have the right context. And again, I wish I could run this locally. Unfortunately, there's a bug on Mac where it will not, if you give it bfloat tensors, doesn't quite work. I don't know what that bug is yet. I haven't really gone through the whole process of debugging it. But bfloat will work on Linux. If you don't, or if you're not using Linux, if you're on Mac OS and you have up to 64 gigabytes of RAM, you can just run these commands right here. Use it on CPU. Do it with float32, and you'll be able to get pretty much the same results. So I'm not going to run it right now, even though it will run. And then you should be able to get results that look like this. There's a huge caveat here. So LLMs, they are very stochastic, depending on the temperature that you set. I had to run this many, many times to get this particular output. Sometimes it gives you total nonsense, like there was a, you know, I don't even remember what some of the generated results were. Sometimes it gives you total nonsense, but it is a very, very small model. It's an early fusion, and early based on time as well as early fusion multimodal LLM from Meta. So as we see, a lot of this work make it into Llama 3 or Llama 4, or Llama 5, whatever, the results are going to be much, much better. But again, I had to write it probably like in a script. I left it running overnight. I picked the best result here. So I cheated. I apologize to everybody here, but I definitely recommend, we'll make this notebook available to you afterwards. I recommend everyone go home, try running it. This is the future of multimodal search, and this is what RAG is going to look like, right? But also beyond that, as I mentioned a little bit earlier, there's many, many other ways that you can use a vector database as well for all these other great modalities. So that's it. I want to thank everybody here for listening to me ramble for the better part of 30 or 40 minutes. Feel free to connect with me on LinkedIn, on Twitter. As I mentioned a little bit earlier, my figurative door is always open, and I look forward to chatting with all of you here.
Thank you so much.